Hi everyone! This video is designed to review with you how to go from a linear table to a linear equation, and from there graph that equation on a coordinate grid. Let's start with the table. The first thing that we need to do with this table is determine if it is linear or not. So to do so, we're going to find the change of y and the change of x to see if that remains consistent, having a constant rate of change as the table continues. We start with the change in y. From -1 to +5, you have increased by 6. So the change in y is 6. From -2 to +1, you have increased by 3. So the change in x is 3. If you continue the table, you will see that the changes in x going from 3, 2, and 2, and the changes in y from 6, 4, and 4 are not the same numbers, but let's see if they have the same slope, the same rate of change. Remember, to do that, we are finding the change in y and we are dividing it by the change in x. So looking at our first pair, we have 6 is our change of y and 3 as our change of x. 6 over 3 simplifies to 2. We have 4 over 2, which simplifies to 2 as well, and 4 over 2, again, which simplifies to 2 as well. Therefore, we have the same rate of change, and that is 2, so therefore our slope is 2. So when we get to our equation, the variable m is going to be replaced with the number of 2. Now we have to identify what the y-intercept is given this table. For my y-intercept, I have to remember that that's the value of y when x is 0. Given my table, I don't have an x value of 0, so I could manipulate the table and plug in a -1 and a 0 to find those values over here for y. But I can also use my thinking of the function machine to help me find that y-intercept. So far, my equation is y equals 2x plus some number. And if I create my function machine, I know that whatever my input is and whatever my output is a value that comes from this table. So let's just use -2 and -1 from my first coordinate pair in my table. So I know -2 goes in the machine and out of it comes -1. So when I put -2 in the machine, I have to ask myself, -2 times 2 is what number? -2 multiplied by +2 is -4. So far I'm at -4. Okay, so what am I going to have to add to -4 to get out of the machine -1? To get from -4 to -1, I am increasing by a value of 3. Now I have this y-intercept. My value of b is 3. So my equation altogether follows the slope-intercept form, where my m was 2, my b is 3. My equation for this table is y equals 2x plus 3. Okay, now we're going to go to graphing this equation. Here's my coordinate grid. I have my equation y equals 2x plus 3 at the top. Now I have to remember, this is my m, this is my b, and I'm going to use the mnemonic of beginning at b and moving with m to help me graph this equation. So if I begin at b, I'm going to begin at the point 3. When x is 0, y is 3. So right now, let's graph that coordinate point. 0, 1, 2, 3. I'm going to put my dot, and that's my y-intercept. That's where my line crosses the y-axis. My slope then is 2, so I'm going to move by going 2 over 1. Remember, I have to put that into a fraction because it is rise over run. And when it's a whole number, I just put it over 1. 2 is positive, so I'm going to be going up 2, and I'm going to be going over to the right 1. So from this point right here, I'm going up 1, 2 over 1, and I'm going to put my point. Now, I only need 2 points to make this a line. I only need 2 points for this linear graph. But if I wanted to make the points in my other quadrants, I could be going backwards. To get from my first point to my second point, to get from here to here, I went up 2 over 1. So if I want to go backwards, I would go down 2 to the left 1. So if I do that, I end up with this point right here. And you can see now I have that more obvious line. And when I make that line, connect my points with my arrows at the end, there's the graph for the linear equation y equals 2x plus 3. Let's do another example. Here's my second linear table. Again, I'm going to prove that it's linear by finding the change in y, dividing it by the change in x, and making sure my rate of change is constant. Going from 0 to 1/2, my rate of change is 5/10, or I could write that as the fraction 1/2. That's my change in y. From -4 to -3, I have increased by 1. Let's continue the table to make sure that it is in fact linear. My change in y continues to go up at a rate of 1/2 for every one value of x. So as x is increasing by 1, y is increasing by 1/2. So my change in y divided by my change in x is 1/2 over 1. And remember, we don't like to leave the decimals in our fractions, so let's simplify this to an easier fraction, which is just simply 1/2. Since my rate of change is 1/2, my slope is 1/2. So in my equation, the m is going to stand, or is going to be replaced with 1/2. Now I want to find the y-intercept. And I can continue this table because it's nice and it goes down by 1 evenly. So hey, look it, I can put in this 0 here. And if I continue that and go up by 1/2 for my y, this number is 2. Okay, so my y-intercept is 2. But let's just double check with the function machine. So my equation so far would be y equals 1/2 x plus some number. And I'm going to take any point from my table. I like this one. And I'm going to put in -2, and out of it I'm going to get +1. So when I put -2 into the function machine, -2 times 1/2. Well, half of -2 is -1. So far I have -1 plus what number equals +1. -1 plus 2, -1 plus 2 equals 1. So my slope, the b variable, is 2. And we saw that in the table too. I just wanted to double check using another method of finding the y-intercept. So my linear equation in slope-intercept form from this table is y equals 1/2 x plus 2. Let's go on to graphing this one next. Again, our equation is y equals 1/2 x plus 2. I'm going to begin with my b. So I'm going to begin at 2, which means I'm starting at the coordinate pair of 0, 2. So I'm going to do that to start with 0, 1, 0, 2 right there. There's my y-intercept. And I'm going to move with my m, which is my slope, and I'm going to go 1 over 2. Hey, it's already in a fraction. My rise is 1, my run is 2, so that means I'm going to go up 1 and over to the right 2. So from this point right here, I'm going to go up 1, 2. Oh, no, just kidding. My rise is 1, so I'm going to go up 1 and to the right 1, 2. And I'm going to put my dot right there. From there, I'm going to go up 1, go over 1, 2, put my dot. And again, if I wanted to go backwards, instead of going up, I would go down 1. And instead of going to the right 2, I could go to the left 2 to put my point there. Now I have my line with my arrows at the end. Here's the linear graph for the linear equation of y equals 1/2 x plus 2. If you're ready to move on to your classwork, go ahead. I'm going to actually start by doing one more example using your classwork to get you started. Otherwise, if you're ready, go ahead and get started. I hope going through this has given you a little bit more clarity. Go back and rewatch it. Ask questions at certain parts if you do have those. Like why did I find my y-intercept that way, or how did I find my slope? So let me know. If you want to stay tuned to look at the first example of your classwork, go ahead. So on Moodle, you're going to find the More Table Equation Graph Practice PDF that you can open in Notability. Please do so and save that in Notability as a note in your Moving Straight Ahead folder. There are going to be 4 of them. I'm going to do the first one with you, and it just really clearly walks you through what this is going to ask you to do. So we're going to get started by looking at our table, and we're going to find the change in y and the change in x. My change in y is, I'm just going to use one of them as my example. From -4 to 6, I have increased by positive 10. So my change in y is 10. My change in x is going from -2 to positive 3. I have increased by 5. So my change in my change in x is 5. So when I go to write this into my table, my change in y is 10, my change in x is 5, and that's my slope. So down below, I'm going to already replace that, which simplified is 2 over 1, or just 2, in my equation where m is. m, 2. Now I need to find my y-intercept. I remember that my y-intercept is the y value when x is 0, and in our table, you'll see that we do not have an x value of 0. So I'm going to, over here, use my function machine method. So far, my equation is y equals 2x. Now we have to figure out what we need to add to that in order to satisfy one of our points in the table. Let's use the point 5 and 10. If 5 goes in and 10 comes out, what happens to 5? Well, 5 times 2 is 10. 10 plus what number equals 10? Well, that number is 0. So our y-intercept is 0. So my equation is y equals 2x plus 0, or I could just write this as y equals 2x. Now let's go to graphing it. B, begin at the y-intercept. And our y-intercept is 0. So I'm going to begin at the origin. I'm going to begin at 0. My slope is 2, so I'm going to move by going up 2. I'm going up because it is a positive number, and I'm going over to the right 1. So from this point right here, I will go up 1, up 2, and over 1. So there I will plot my first point. Again, up 1, 2, over 1. Now, if I wanted to put a fourth one in my other quadrant, I would go down 2, so the opposite of going up 2, and the opposite of going to the right one is going to the left one. Put my dot there. I'm going to connect my 4 dots as best as I can to make my linear graph for the equation y equals 2x plus 0, or again, that would just be y equals 2x, that I got by looking at my table over there on the top of the page. You'll have 3 more examples like this for your classwork. Again, find this in Moodle, open it in Notability, and save it in your Moving Straight Ahead folder. So for the rest of class, your task is to complete the More Table Equation Graph Practice, again, found on Moodle, and your homework tonight will be Brain Genie Goals, also titled More Table Equation Graph Practice. So go onto your Brain Genie. On the left column, you will see the little tab that says Goals. Click on that. Click on the little section called More Table Equation Graph Practice, and you are off to doing your homework. Good luck. Let me know if you have questions.
Made with Doodlecast Pro.